Assalamualaikum warahmatullahi wabarakatuh. My name is Yan Fadian Nabila with student ID number 1104202006. And this time I want to present about a paper with the title Design of Digital Infinite Impulse Response Filter based on artificial phase charm algorithm. Digital filter is an important part in the field of digital signal processing technology. And the digital filter design may have two types. The first type is design an analog filter according to the design requirement, and then transfer it into a digital filter to an analog to digital converter. And the second category is to use the biological intelligent optimization algorithm. Okay, next, the basic idea of using computer-aided design method for digital filter design is the first, determine the frequency response function of the ideal filter according to design requirement. The second, according to the character of the filter, the mathematical model of the filters. And the third, solve of the mathematical model with the optimization algorithm and get the amplitude frequency response curve of the design filter. The system function of the infinite impulse response digital filter is expressed as like this. You can see from the first function, it's z. You can see that, and then among of them, B0, B1, and the others, and I1, I2, and IN are the parameter of digital filter. If the Formula 1 is used to design the IIR filter, the number of target parameters that need to be optimized is Q plus N plus 1, and the value range of the parameter is uncertain. And then, when N is a number of second order nodes, A is the gain, A key, B key, C key, D key is the parameter to be optimization. Using the Fourier transform, the frequency response of the IIR digital filter. So, in the third function is after using the Fourier transform. And the last, the square error of the amplitude frequency response between the design filter and ideal filter. And the next, artificial phase charm algorithm, behavior analysis. For behavior analysis have more types. And the first, foraging behavior. The second, swarming behavior. The third, following behavior. And the fourth, random behavior. And this time I choose following behavior because the artificial phase will move one step to the position of the optimal phase. You can see the function where DIO represents the distance between the artificial phase and the optimal phase. Otherwise, it performs foraging behavior. This case implementation of artificial phase charm algorithm with IIR filter optimization. The techniques of this, we use the function you can see in the PowerPoint. This is the technical indicator of the ideal low-pass filter, and then the amplitude frequency response curve comparison between the designed digital low-pass filter and the ideal low-pass filter is shown in the curve. The solid line is the ideal low-pass filter, and the dashed line is the design IIR digital low pass filter. It can be seen from the feature that the passband cutoff frequency of digital filter design with the artificial phase charm algorithm is about 0.3 V. The passband ripple is relatively large, and the stopband cutoff frequency is about 0.62 P, which is similar to the amplitude of the ideal digital filter. And the last conclusion, the power of IIR filter comes from the flexibility provided by feedback setting. And the second, the artificial phase charm algorithm is used to optimize the design the digital low-pass filter. And the third, the amplitude the frequency response curve of the design low-pass filter is given with IIR filter. Okay, maybe that's all. Thank you for your attention.